Okay, in this question we are going to look at the geometry of lines and circles. So we've got a line and we're going to show that it does not meet this circle. Well, to show that it does not meet the circle, let's try and show that it does meet the circle. Let's try and show where they cross. So we're going to try and solve these two simultaneous equations. So you've got two equations here, and we're going to solve these just like a pair of simultaneous equations. So we can see that y here equals x minus 10. So I'm going to replace the y with x minus 10. So I'm going to take this equation and replace the y with x minus 10. So x minus 2 squared plus x minus 10 all squared equals 25 when I do that. And let's multiply out the brackets and simplify. So I get x squared here and I get x squared here, which will give me 2x squared. X minus 2 squared, let's do a little bit of side working for this to get a bit more out of it and make it easy to see where it all comes from. If we do the FOIL method of multiplying out, first two things times together gives me x squared, outer two things, this and this, gives me minus 2x, inner two things, this and this, minus 2x, last two things, this and this, gives me plus x, sorry, plus 4. Minus 2 times minus 2 gives me plus 4. So I can see I'm going to get a minus 4x plus 4. Now if I multiply x minus 10 out in the same way, I will get x squared minus 10x plus 100. So let's put that in. I've already added in the x squared to get this x squared here and this x squared here. I've added to get the 2x squared already. So I just need to put in the extra minus 20x. I've got a plus there, let's just rub that out. So there's that rubbed out. And we're going to put a minus 20x plus 100 equals 25. And now let's just group all my terms together. So I get 2x squared minus 24x. I've got 4 plus 100 is 104. I want to take off 25 to get everything on the same side. So take off 20, that gives me my 84. Take off 5 gives me 79. So plus 79 equals 0. Now I'm trying to show that this line here does not meet this circle here. Now if that's true, there'll be no solution. So I'm looking for a situation where there's no solutions. Therefore, I'm going to look at the discriminant. And the discriminant is the b squared minus 4ac bit. And I need to show that this is basically less than naught. Yep, because if you remember the formula, I end up squaring, for the quadratic formula, I end up square rooting this. And if I get this is negative, I can't square root this, therefore there'll be no solution. So let's look at b squared minus 4ac. So I'm going to get 24 squared minus 4 times 2 times 79 for the discriminant. So let's just give myself a bit more space to do the working. So 24 squared is 576 minus 4 times 2 times 79 is 632, and we can see this is less than naught, therefore no solutions. Therefore the line does not cross the circle. Okay, now as I give myself a bit more space to work, just examine the circle situation. Okay, I'm just going to draw myself a quick circle. Here we go. There is a circle. Now I can have three situations with my lines. I can have the situation we've got here, which is where the line doesn't cross a circle. I can have the situation where the line just touches the circle. Imagine it just being a tangent at that point. And then we can have a situation where the line crosses the circle. And obviously there are lots of different places where this can happen. But the conditions we have for each of these here, b squared minus 4ac will be less than 0 when we combine the two equations. Here we'll find that b squared minus 4ac will equal 0. Okay, that gives us just one solution, and here we will find we'll have positive answer for b squared minus 4ac when we've combined the two equations. Alright, you must have a value greater than 0, and that will lead to two solutions. Basically, if you work through the problem that we've got, actually for both these two, you will get answers. You'll get one answer for that one, and you'll get two answers for this one. It's just here that you realise that you get no solutions, just like the example we did. Okay, so for all these types of questions where you're looking for a line intersecting a circle, right, if you just solve them as normal simultaneous equations, you'll ever get to a situation where there are no solutions, as we did in this question, alright, and the line doesn't cross the circle, or you'll get one solution, therefore it's a tangent, or you'll get two solutions, therefore it must intersect the circle in two different places, two distinct different places.